Hello, 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 everyone. Today we are here with an amazing panel, and I'm super excited for this series. For those of you who don't know, we are going to be running like one event every month till KubeCon North America, and then one big event during KubeCon North America with data on Kubernetes, which will be focusing on more on hands-on technical stuff, like getting started with Docker, containers, Kubernetes, networking, and all these things. I'm not going to ruin it for you, but there's a lot of nice things planned. And then we'll have like CIVO community events as well, more like about community talks, like starting with open source, roadmap to from college to cloud native, about certifications, things like that. So first of all, thanks a lot for joining, Bart, Nelly, and Jeff. Bart has been on our channel for quite a lot of time, and before we even get started, check out the links in the description for data on Kubernetes. Because if you don't do that, then you're like missing out on 80% of this webinar. That is the most important thing you have to do right now. Check out the links in the description for data on Kubernetes. I see 200 plus people are watching. So please show some love and check out some amazing content over there. Alrighty, Bart, let's do some introductions. First of all, would you quickly like to introduce yourself? Let's start with Bart.
Absolutely. Yeah. Hi, everybody. Amazing to be here. Namaste, everybody. Welcome, welcome, welcome. I got some coffee. I got really pumped up by that warm-up music, and now I kind of got to settle down a little bit. Anyway, it's really good to be here, as always. As Kunal said, it's not the first time. Yeah, Jeff's dancing. I kind of want to dance. I kind of want to stand up. I need a standing desk. But anyway, it's always good to be here. Why? Because it's all about young people. It's all about interacting with young people. It's all about making that journey easier. And we are fully committed to doing that in our community, and we want you to be a part of it, all right? No one has too low of a level, whether it's in the DoK, CNCF, et cetera. We really want you to be a part of it. We want to take your feedback into consideration. And that's why we got a little bit of a challenge today to see how well we're explaining stuff and then to hear back from you. So no pressure, Jeff. That being said, I would like to introduce our speaker, who is a longstanding member of the Data on Kubernetes community, gave a talk alongside Kunal as well in our Data on Kubernetes Day that we did in May in KubeCon. So Jeff, who are you? Where are you? What are you doing? I just also have to say, in terms of intros, I'm normally in Spain, but today I'm joining you from California. Jeff, where are you at?
I'm in Scottsdale, Arizona, the Sonoran Desert, and it is currently 86 degrees. It's going to be cranking up to a little over 100. So we're pushing 40 Celsius today. We won't get to 45 until next month, and then maybe after that it rains. I hope in July. Yeah, so I'm super excited to be here. This is a great community that has been forming here with the Data on Kubernetes community. Fantastic, dedicated day that we had as part of KubeCon Europe, mm-hmm. And we're gonna do another one in the fall in Los Angeles, right?
That's correct.
Yes, awesome. Looking forward to that too. And I'm loving the opportunity to the merger here with the student group. This intersection is phenomenal. And like what you said, Bart, like if we can't explain things in a way that everyone can understand, then we still have work to do. So I'm going to give it my best shot today.
Absolutely. That being said, just a reminder to everybody, we want questions, all right? This is supposed to be interactive. We want to engage with you. If for whatever reason we don't get to your question in the chat on YouTube, please just jump in our Slack. We have a dedicated channel called Beginner's Questions. No question is too basic. No one's going to shout at you for asking the wrong thing. We may redirect you to some resources so you can get some background information. Would highly recommend checking out the video we did with Kunal, Code for Cause, and the CNCF students group, the launch that we did a few weeks ago. A lot of good links in there, a lot of good starter information to get going. But if you need help getting oriented with that stuff, just feel free to ask. Another thing that I'll explain briefly, but something that makes later on, something that makes our community very unique, is that many of you know that we have rap videos, but we also have a strong commitment to working with art, which is why I would like to introduce the next person, who's Nelly Toby, who's our visual learning coordinator. If you check out our Twitter, you'll probably see plenty of different drawings from Nelly, also in our Slack. Nelly also created our first coloring book that you can find on our website. You can download for free. And so you can check that out and get started with the artwork that's there. It's a great way to bring concepts to life. So Nelly, who are you? Where are you? And what do you do for us?
I'm Nelly. I'm from Michigan. I'm a Michigander. Gotta have the Great Lakes. I am attempting to learn Kubernetes. I'm getting a pretty good start on it, and I try and take the concepts as I'm learning them and draw them in ways that other people can use as a visual learning tool. So it takes this big complex thing and make it a little bit more gentle.
Absolutely. A little bit more gentle, a little bit less overwhelming. Don't worry for folks that are out there that find this stuff really crazy. We understand. We're with you. And that's exactly why we're here today. That being said, Kunal, is it cool if I share my screen to just do a quick presentation?
Yeah, that sounds good. And for those of you who are joining, I just want to share, do ask questions, because if you do ask good questions, then we do have like some nice prizes for you as well. I just want to give a shout out to Sivo for sponsoring some nice mugs and stuff, and mugs and like stickers. And we also have some coupons that I got like from CNCF for like you can get anything from the CNCF store. But yeah, most definitely. And Bart, do you want to share about it right now?
Will do. Happy to do so. Yep.
Data on Kubernetes one.
Yeah. So this is just a real quick presentation just for folks that don't know us. I'm going to go through this really quickly. If you want more info, just like I said, contact me on Slack, Twitter, LinkedIn, whatever you want. So the Data on Kubernetes community was started last year in June, and I got involved last year in around September. And so since then, I've been leading the community. As I said, I'm currently in California, but normally I'm located in the north of Spain. I started working in tech 6 years ago, always related to talent management, event organization, in the times when we had physical meetups, organizing events in that sense. And since then, I've been involved in different projects, audiovisual production, et cetera, et cetera. And now I'm currently, I have the good fortune of leading the Data on Kubernetes community. And you're going to get more of an idea what we're about once Jeff gets into his presentation. Like Kunal, I'm also a CNCF ambassador, so very, very happy to be working with the CNCF. And particularly really happy to be working with students. So you'll see some of the stuff maybe a little bit later on about some of the things that we're doing with students. Other stuff, what is the Data on Kubernetes community about? So basically this challenge of working, as it sounds, working with Data on Kubernetes, the issues that we encounter, whether it's with databases, whether it's with operators, whether it's with chaos engineering, the different skills that you need to have to be able to work with this. And why we're here today is, maybe sometimes we have content that's for practitioners with more experience. But as Jeff was mentioning, we want this to be accessible and available and understandable for anyone at any level. All right. So like I said, we're very, very much committed to that. Our community's grown a lot in a short period of time. You'll see on LinkedIn, you'll see on Twitter. All right. No need to go too much into detail, but we've had over, if we count the talks that we've had from KubeCon as well, we've had over 70 meetups. This is officially, I think, our meetup number 52 or 53. But like I said, we've been very, very active with lots of stuff. I actually have another meetup after this one. So anyway, we're very, very active in that sense. Another thing that makes us unique, as I said, we have a coloring book that Nelly created. We have artwork after every single meetup. We have musicians. We do crazy videos. You've seen the raps, all that kind of stuff. But the way that we look at it is that why can you not have fun and learn at the same time? So we generally believe that if you can create a fun environment where people can participate and interact and learn, meet people from different countries, different cultures. Also said we do meetups in different languages. We've done meetups in Spanish and Portuguese, in Hindi. I want to do one in Russian in the next few months. We're very, very open to that kind of stuff. So that makes us different. If you want to get involved, like I said, check us out on social media. Ask questions, all right? Speakers want to be asked questions. Jeff wants to answer your questions, all right? So if we don't get to your questions for whatever reason with the YouTube chat, please jump into our Slack channel. Like I said, we have a channel just for beginner questions. So definitely get in there. Other ways to get involved, we're working on some more official things as a community. So in the next few months, there should be some news about opportunities for menteeships and internships. All right. But there's, like I said, lots of different ways to participate. You don't have to be an expert on Kubernetes to be involved in our community. All right. That's not a requirement. All right. It's not a requirement. There are tons of non-code, contributions or non-technical ways that you can be involved. It's just about being nice and being enthusiastic. Right. That's really what's important. So if you want to get involved in something like that, please just contact me on Slack. Now, your mission today, some people were already asking in the YouTube chat, so I just want to address this directly. All right. Just going to give his presentation about the intro to Docker. While he's giving his presentation, I'd like you to write down your observations, your notes. You can just type it out in a blank document, things like that, just high level kind of ideas. You'll obviously have access to the video very, very soon. Jeff has also given me his slides. I will post those in our Slack, all right, in the beginner questions channel. So you can see all that there. Basically, it's really simple. You're going to write the maximum 250 word summary of the things that Jeff has talked about. All right. But like narrating, think about like storytelling. Hello, my name is whatever. And today I'm going to tell you about the things I learned with Jeff Carpenter in this session that we did, however you want to frame it. So just have it organized, cover the main key points that he explains, and then have a conclusion summarizing the stuff that's there. Once you've done that, all right, find me on Slack and send me your summary. All right, the deadline is tomorrow. All right, this is going to be done quite quickly. We want to get this moving so that we can have everything ready to go for next week. The winner will have their summary created into a video. All right, a video where you will record your voice narrating it. All right, just reading your text. And then we will correspond with images and animations to give you a custom-made video explaining what Jeff has explained, but in a summarized format, once again, so that we make this even more accessible for folks that are your age, right? So the winner will get a video and some swag. There will be swag for the second, third place winners as well. So like I said, we really want to hear from you. We want to get your participation, your feedback, etc. This is your time. That's pretty much it. In terms of questions, you got the website, you got Twitter, all this stuff as well too is in the description that Kunal very nicely put in the YouTube in where you're watching right now. So if you want to get those links as well, it's all there. I already posted our Slack channel once. I'll post it again if you want to hop in there. And we can get, that being said, I think we can get started. So Jeff, without further ado, it's all yours.
Just one more quick thing. You'll also we'll also select like 20 more people for some additional swags that we have. And that is also something I'll be also reading like the essays and stuff, and they'll get like mugs and stickers and coupon codes and things like that.
Please participate. Please participate. That's
please
all
participate.
Yeah.
The most important thing is like learning and getting involved and showcasing whatever that you are doing. Please share about it as well, like on socials and stuff. Feel free to tag us and share what you learned. And yeah, most importantly, your learnings via a blog and something. Cool. I believe we can see the screen now. But if you could just share with me the Slack link, I'll add it in the description.
Will do. I will do that right now. Okay.
Jeff, you're on mute.
Oh man. Rookie mistake. Okay. Great. So I'm super glad to be here and getting started with this. I see a bunch of questions rolling in already. I will try to do my best to roll them in context. My crew here is going to hold me accountable to anything I didn't answer at the end. And okay, so I think we should start with just kind of a roadmap of where we're going with this series. So today we're just going to be talking primarily about Docker. Because this is data on Kubernetes, I'm going to try it for today and the talk I give today, and working with the speakers who give the other talks, that we will try to work in a little bit of data. How do we do data with these technologies? Because that's some of the piece that is missing from a lot of the education. There's tons of educational content that's out there on Docker and Kubernetes. It's sometimes hard to know where to start. So I'm going to give you some pointers about some places that you can start looking, especially with respect to data in Docker and data on Kubernetes. So today it'll just be about Docker, kind of building blocks of things. We'll get into Kubernetes next month. And start talking about actually how you store data on Kubernetes in August, and then actually deploying databases on Kubernetes for September. That's kind of the rough roadmap. All things are subject to change, and what meets your needs and speaker availability and the price of cotton. I don't know what it depends on. So let me tell you a little bit about what the outline of this presentation, what we're going to be going through. I am going to answer what is Docker. I am going to answer why do we need it? A little bit about how it works, a little bit about data in Docker containers, some suggestions, like I mentioned, on how to learn it, lots of answers to your questions, and then a little bit of career thoughts, because I know a lot of folks like to ask questions about how did you get where you are? How can I get where I want to go? So we'll try to hit a little bit of that at the end and try to leave some time for Kunal to make sure that we can talk about open source contributions and how to get involved. Okay, we can do all this, right? Totally. All right. What is Docker? So I think we need to talk a little bit about kind of a story. Just a few years ago, I was working at a company, I guess I won't name it right now, but We had a pretty major software project, and the delay of this project, the start of this project was delayed because of the simple fact that we could not get the infrastructure that we needed. Now, this means, compute resources deployed. We needed to be able to have machines to deploy our software so that it could run in the production system. And we were delayed weeks because there was some other organization that was responsible for provisioning virtual machines, not even real physical hardware, just spinning up virtual machines for us on some infrastructure. Docker comes along and really upsets this whole apple cart of what it takes to deploy infrastructure. Now, yes, there still has to be some compute resources somewhere available, some actual physical hardware that things are running on, but it has really begun to make it easier and put power in the hands of developers to actually deploy and spin up software, and then shut it off and throw it away. So that's made a lot of great advances possible. The whole continuous integration movement, if you're familiar with that, there's some of these things that were really unlocked by the ability of having these Docker containers that we could just spin up and then throw away. So about 25 years ago, Sun Microsystems invented the Java programming language. And the whole theme of that was the ability that you could write a program once and you could run it on any operating system. So application portability across operating systems. Docker actually changes that abstraction so that you can write any piece of software and run it. So as long as it can run on some operating system, the idea is that you can put it in a container and that it can run anywhere, and it doesn't have to be even a Java program. It could be whatever programming language you want. So we're actually shipping code, the application, along with its dependencies as a package, and that's in a unit called an image. And then we create instances of that, and running instances of those images are called containers. So the image is kind of like the recipe, and the container is the cookie. I just made that analogy, so if it works for you, great. If not, please forget it immediately. Okay, so what is Docker exactly? Some people get confused between the idea of virtualization or virtual machines and containers, and what's the difference between those? So a virtual machine is where we're actually running an instance of an operating system on top of another operating system. And there's usually some kind of layer called a hypervisor, which is a program that takes an operating system and runs it on top of another operating system. So you see in this picture here, there's 3 virtual machines, and each one of them has an application and an operating system it's running on. And then that's all being run on top of the hypervisor, which is mapping onto the host operating system. This is still a fairly heavy weight, uses quite a bit of resources. The idea of containers is that it strips it down even more. You don't really have to run a full operating system on top of a layer that maps it onto another operating system. That containers run as processes in the host operating system. They just look at the inside of the container. It looks as if it has its own little operating environment, but to the host operating system, it just looks like any other process. So it's a much more lightweight approach. Now, the technology for this and the idea of this is not new. Docker's been around for a decade, but the concepts of this are older than that, and actually maybe 20 years old in the Linux community. So we have this idea of Linux containers, which allowed you to run multiple operating system-like processes within, or divide up a Linux operating system into kind of multiple kernels that you could run different applications on. So think of containers as being a really lightweight way of deploying an app and its dependencies without having to have, the full infrastructure of a physical machine or a virtual machine. The idea is that they're very lightweight and disposable. So this just is a way of allowing, this slide allows you to see those pictures kind of side by side. As you can see, containers can tend to run pretty fast because there is a little bit less abstraction between what's running in the container and what's on the host operating system. A lot of people have looked at the trends of putting everything in containers and wondered if virtual machines themselves are going away. And I would answer no to this. There are plenty of companies are taking kind of legacy workloads that they have, all the applications that they've been running for many, many years in a lot of cases, and to the cloud. Usually they just take applications that they have, virtualize them, make them run in virtual machines, and then they begin this process of breaking them up into microservices maybe, and then they might deploy each microservice in an individual container. So most enterprises of any significant size, if you were to peel back the lid on what's in their IT infrastructure, you're going to see a mix of things. They may have their own data center. We're not even going to talk about that. If we look in their cloud account, you're going to see a mixture of virtual machines running and containers that are running different microservices. And all of these are valid. What you may also see is there's a trend toward functional programming or functions as a service, or what some people call serverless. That's even more lightweight than containers. I just want to mention that. We're not going to dive into it any further because I don't have time today to really get into that. Maybe we would put that on the roadmap for a future event. So now that I've explained a little bit about Docker and what it's trying to do, I want to talk about why we need it. So I mentioned already my story about how long it took on this project to get our infrastructure deployed. Docker really speeds things up. You can deploy applications quickly and you can throw them away quickly. And you can take applications, as long as you can deploy it to a container, you can run it on your desktop. So you can get, like, I have Docker desktop, I have Docker running on my desktop. It's actually a virtual machine that can run Docker containers inside it. But also, you're a cloud provider that you may be using for school, or if you have an internship, or if you have some professional experience, like whatever cloud that they are using, you have the ability to deploy containers there as well, generally, if you have the right permissions. So I can run the same container exactly on my desktop, and I can run it in the cloud. And it's the exact same container. Now, you may have heard sort of like there's a classic developer line, which was, it worked on my desktop, right? I ran the program and it worked on my desktop. And then that's like the developer excuse, like, well, it broke in production, but it worked on my desktop. Have you ever heard this? Yeah, okay, I'm just checking for some head nods out here. So the portability of Docker means that you write it once, it runs the same on your desktop that it does in whatever Docker provider that you're running. So that gives you that independence and frees you as a developer from having to depend on an infrastructure team to deploy your application in a lot of cases. Again, as long as you have the right permissions on your account. It's also super efficient because containers are lightweight. They use less resources. Now, I have seen in the past cases in which a microservice architecture was deployed, and there was actually a single microservice running per entire virtual machine. So think about this. There's a whole full operating system running on top of another operating system and has your application in it. And your application probably isn't even using most of the capabilities of that operating system. Super wasteful. So containers are more compact, more resource efficient, therefore less computing cost, which is what this is really getting to. This all boils down to how much does it cost to develop these applications, how many resources, CPU cycles, and electricity are they consuming to run them? in the end, it does all kind of boil down to cost. So let's dive in. We're going to look under the covers a little bit of Docker, how it works. Now, this is the point at which I'm going to talk about some of the commands of Docker and a little bit about how it works. I'm not going to expect you to be running anything right now. I'm going to point you to resources that give you exercises that you can do. So in Docker, we build images, which are kind of, again, this recipe or what is the application, the definition of the application, and then we deploy. Every time we deploy an image, we get a container. That is a running instance of an application. So a Docker, it's immutable once you create it, and then it is what it is. Okay, you don't change a container. It's a blueprint, and then you stamp it out. You take the blueprint, the cookie cutter, form the cookie, and then bake the cookie. That's the containers. So you can build an image, you can lots of container using an image, and you can delete an image. Another analogy that some people find helpful if you're into object-oriented programming, the image might be considered the class, and the container might be considered an instance of that class, which is called an object. So again, hopefully that is helpful if you have that background. So the container is an instantiation of the image, and that's it's a deployed instance of an application. You can start containers, you can stop them, you can run commands against them. They have logs, so you can watch their logs and so on. Okay, so there's two ways that you might interact with this. One of them is if you're an application developer, you may actually be building an image of your own application. You can also make use of containers that are built by others. So that's another way in which you might interact with this. So if you're going to build an image, which you write something called a Docker file. So what I have here on the left is an example Docker file. And it basically is, this says that, I'm just going to kind of translate what you're seeing here real quick. So this from statement says there is a base image that we are starting with. So we're going to take an image that was created by someone else as our basis. It's an image that has Python in it, Python 3.8. We're going to add an entry point to that. And this is defining what's the command that's going to be run when this container is started. There's environment variables that we're defining. So we're going to define an environment variable, which we can actually override when we start the container if we want. We're going to tell through this work directory, we're going to tell the container runtime what what directory the command is that we want to start to build this image. And then we're going to copy some files into the image that's basically our Python application that we're going to run. We're going to use a run command to say some things that we need to execute inside the container as it's being built up. Maybe we have to grab some files. Maybe a little setup script needs to run. So there's a whole series of steps and commands that we have available to us that we specify in a Docker file that allow an image to be created. So we may start from a base image. That's usually what you do. That basically has the language runtime that you need, like Python. Then you're going to add your Python program to it and tell the other instructions are basically telling Docker what's the command that you want to run when a container is started. So again, this is pretty high level explanation. There's way more that we could dive into. I'm just trying to get the high points for you. So the commands, the four main commands that I went over there, from, that's the image you're starting from. Copy, these are your application files that you're copying in. The run, these are my setup things that you need to do inside the image. And then command is the actual command that's going to get executed when the container starts. Okay, so we define a Docker file, and then we run the Docker build command, and the Docker build command takes our Docker file and uses that to create an image. you can actually list out what images you have within your local copy of Docker by this Docker images command. And then if you want to see what they are, and then you can also run an image. So this is where it gets fun, right? You take an image and pass it to the run command, and it starts a running instance of a container for you. You can use the Docker PS command, which is kind of similar to the Unix PS, which does what? Lists out the processes that are running. Okay, so if you're in a Unix system, PS lists out processes. Docker PS lists the containers that are running. And it'll give you, containers are referenced by a unique identifier. So what you do is Docker PS, it lists out the containers that are running. I'm going to show you this in a little bit, but it lists out the IDs and names of all the containers that are running. You can use an ID of a container to tell it to stop, or you can attach to it and execute a command against it using that ID, etc. Docker RM deletes a container, and Docker image remove, or you can also say Docker RMI, that removes an image. So you can start and stop containers, you can remove them, and you can remove their images. Now, you can also take an image and share it with someone else. So to do that, you need something called a registry. So a registry is a place where you store copies of images that have been created. Docker Hub is a public registry. So a lot of people, most of the images that I use on a day-to-day basis come from Docker Hub. You can also run an internal registry inside of your organization. So a lot of people have build processes that they compile the code, build an image, maybe run some tests, and then the image gets pushed to an internal or an external repository. So some of the commands that you use, Docker pull is grabbing an image from a repository. Docker tag puts a tag or an identifier on an image, like a version number, for example. And then you might tag an image so that other people won't know what version it is, and then push it to a registry. And in order to interact with the registry, you probably need to have some authentication and some credentials. So Docker login is the command that allows you to actually log into a registry and assert who you are, so that you have permissions to do things like push an image. So again, high-level overview of kind of what are some of the commands that are available. Okay, so this is great. How do I build apps with Docker? Like, let's say that I actually have a fairly complex application. I might have a front end that is my application front end in Node. I might have another front end that's kind of an administrative back end that's doing some things. I might have a caching layer or a database. This application has both. I may have some Java workers that are doing different things. Maybe these are different microservices, for example. So let's say that each little icon on this diagram here represents a different container that we want running in our application. This is kind of a cool design because if we have our application divided up into containers like this, if we're doing things right and designed for it, we can actually scale our application by running different numbers of the different containers. Like maybe I have more traffic come in to my system, so I need to run more of my my Java workers, running more instances of those, and I could just do that by spinning up more containers. There's a lot of things that you can do with this in an architecture of a system that we probably don't have a whole lot of time to go into right now, but this is a really nice design if I have my application divided up into multiple containers like this. But how do I hook everything together is the question. So that is what Docker Compose is for. Docker Compose allows us to write out a recipe for basically the ingredients, like all of the containers that I need to form an application and wire them together. And I can do this declaratively. I write a file. And so I'm basically doing, if you've heard of infrastructure as code, I'm writing a YAML file. It's code. It describes the entire layout of my application composed of different containers. And that's very repeatable. I don't have to do it by hand each time I want to deploy this application. The recipe is all written down in this Docker Compose file. So let's look at one of these real quick. I'm not going to go line by line here, but I'll just point out a couple of things here. So this is a Docker Compose file. You can see it probably goes on for many more lines than this, but the very first services that we see here, there's a WordPress image or a WordPress container that'll be based on this WordPress 551 image. And then it has some environment variables that we're using to configure it. It has some ports that we're telling it to open up. We're saying that it actually has dependence on another service, which is the database service. And so then we see the definition of the database service. And that's running a MySQL database. And it also has some environment variables that are passed to it to configure things like what is the username and password that should be used and these kind of things. So you can see here that this application could be considerably more complex, but already we're seeing some of the value of this Docker Compose file where I'm deploying WordPress in one container, MySQL in another container, and then I'm setting parameters or configuration values that are allowing them to be set up to talk to each other and access each other's ports as needed, get the right security credentials so that the application can correctly authenticate to the database. Yes, this can all get pretty detailed pretty quickly, but this Docker file is a really powerful way of writing this down once and for all so that I don't have to remember it every time I want to deploy this application. So once I've written my Docker Compose file, then there's a command called Docker Compose, and I can write Docker Compose up -d, and the application just deploys with a single command. So pretty awesome. I've gotten, this has saved me a bunch of time over the years. So Docker Compose, there's a number of things that you can do with it. Docker Compose allows you to interact with the containers that it starts using a lot of the familiar Docker commands that we've kind of briefly introduced before. The corresponding command for Docker Compose up that spins up everything that's in your Docker Compose file is Docker Compose down. And then that destroys the entire application, brings the whole thing down. So saving time on startup, saving time on teardown. These are great, great things. Okay, I put out an opportunity for asking questions before the workshop. And I got this one, I really liked it, I put in the slide. So from Kawalia, how do we set Docker up on our local project as well as use it if it's present in the project that we want to contribute to? So I do recommend for projects that you're working on that you do, this is the friendly way to make your project, let's say you're working on an open source project or you want to collaborate with others, and you're writing code in whatever language you choose. A really friendly thing to do is in your repo to provide a Docker file. Somebody can use that to build an image. So let's say they're hacking on your code. They can use the Docker file that you've provided to create their own copy if they're hacking on your app on their own version, and then deploy it in Docker. The other thing that's great about providing a Docker file is maybe you actually choose to publish publish an image for your application in a public registry. So maybe people can actually just deploy your app. Maybe they don't have to clone your repo and build it themselves. Maybe they can just go to Docker Hub and pull down your application and run it that way. Super friendly, super accessible. So I highly recommend doing that. I also recommend, if you have an application that you're writing and it actually maybe, I don't know, you're writing an application and it depends on a database, for example. Why not provide a Docker Compose file as part of your project that leverages the image that you created, as well as, you know, pulls in any runtime dependencies that you have in other containers. So always great to make a Docker file as part of your open source project. Always great to provide a Docker Compose if it makes sense, if you have an environment that needs multiple containers. I think that's the spirit of what the question was. So hopefully I did a good job of answering that. Okay, so now this is data on Kubernetes, folks here. So where does all the data go when I have containers? Okay, this is going to look a little bit complicated, and the commands are going to look a little bit complicated. Let me boil it down for you real quick. So on this diagram on the right, you see that we have a container. It's running in memory, and it wants to access data that's on disk somewhere. Now, there's two ways that Docker allows you to do this. This first arrow here that's kind of on the left side of the diagram shows a container that is accessing what's called a mount. So this is kind of like the quick and dirty way. Okay, so a container can access a directory on the file system, directly on the file system of the computer, and that's called a mount. This is really great if you're in development mode. So like this command here, Docker run -v for volume. It is mapping Anna's project directory into the container, into the /app directory inside the container, and it's read-only. So the application, a running container would have read-only access to the contents of Anna's project directory on the host operating system. But Anna's home directory, when you go and deploy this in a cloud somewhere, Anna's home directory isn't going to exist. So file system mounts are great for local development, but not for running containers in production systems. So that's why Docker has this other system called a volume system. And so you see here on the lowest part of this diagram, when you install Docker on a Docker runtime on a computer system, such as your desktop, you're actually giving it access to the computing resources of your computer, right? The CPU, the memory, and you're giving it some space on disk. So Docker is now managing part of your hard disk, and Docker can control the allocation of this disk space and manage it itself. So this is the more robust way. These Docker volumes are the more robust way. Now, this is something that I'm just kind of putting a placeholder here for this conversation, because we're going to come back to this in future talks. So volumes is a concept that exists in Docker, but it's also an important concept in Kubernetes. So as you're learning, you want to understand how Docker represents volumes, and then that's going to give you a leg up on understanding what volumes are in Kubernetes. Because the term is the same, the concepts are very, very similar. All right. So, hey, where am I at on time?
How much you have left, but I would say 10, 15 minutes.
Okay, perfect. Okay, so these slides are gonna be available afterwards. I think I'm gonna not demonstrate this part to you in the interest of time, but you will have these slides and the ability to execute some of these things on your own. So let me tell you what these commands, let me give you the decoder ring for this slide, okay? This slide is gonna allow you to experiment with creating volumes and these bind mounts. So the idea here is we're going to deploy MySQL, the database, 3 different ways. The first way is we're not going to use any volume at all or bind mount. So if you run MySQL, it's going to run, you can actually shell into it and write some data. But if you kill that container, the data is going to be gone. So that's this first command here. So if you run if you run this first line here and then actually go and attach to the database, write some data, and then delete the container, you'll realize the data is gone. If you take this second option here, then you can actually mount a directory on your account, on your computer. And if you do this, you'll see that the data is stored in the directory on your hard drive. And if you kill the container, the data is still there. And then the third option is to use Docker's volume system, where it's managing data on your computer. So you can run through the same exercise 3 different times and see how the data is persisted in different ways. That gets us kind of to the next topic, which is how can I learn Docker? So there are a number of great resources out there. Plenty of courses on Udemy, Code Academy, like various other sites. What I want to share with you is some things that are specific to the data aspects that I'm familiar with. So a colleague of mine, Alex Vlachnev, has done a great course that some of these materials that I'm sharing with you today actually come from this course that Alex did. I did kind of an abbreviated version of it. So he's got Docker Fundamentals, Part 1 and 2, App Development with Docker, Succeeding with Docker, and then there's kind of a bonus 5th episode, which starts to bridge into Kubernetes. Yes, I realized the counting error where it says full 4-part Docker course and there's 5 videos. That's why the Kubernetes piece is the bonus to bridge you into other materials like Cassandra on Kubernetes. This is a course that we have at datastax.com/dev. So we recently started offering a certification for running the Cassandra database on Kubernetes. Now I know that's definitely like 3 steps past what we've been covering in this talk today. But if this is something that you're interested in, you can actually go and take a course that we have on the website. It's based on Katacoda, which is a great way to learn because it's basically embedded in your browser. So you don't have to download and install anything. You just go to the website. This pops up in a whole environment in your browser. And the most popular, I think I blew by it pretty fast, but this course, Apache Cassandra Operations in Kubernetes, and I'll drop a link here in a minute, walks you through creating and deploying an entire application in Kubernetes on top of Cassandra. But unit 2 here is just running Cassandra in Docker. So if you're just kind of starting and wanting to learn what is this idea of doing data or databases just in Docker, you can go through this exercise and it actually shows you, it walks you through step by step. And you actually, when you pull this up, you click on everything that has like this little arrow in it, the little return button in it. You basically just click on these things and read the text, and it walks you through executing this whole application. In this case, deploying a Cassandra node in Docker. So this is a really great way to learn. But then if you want to get like, just start experimenting and doing stuff, there's also this labs.playwithdocker.com. Again, you don't have to install anything on your desktop. You can just run all of this in your browser and just do like maybe a little bit more free form experimentation. So these are a couple of resources that I've found really helpful in getting up to speed and running things. And now for an abrupt transition. Okay, so I wanted to talk a little bit about what my career path has looked like and allow you to ask any questions. Now, this is not something where you have to ask right now in YouTube chat or forever hold your peace or anything like that. I just wanted to share a couple of things that have helped me over the years that I wanted to pass on to you, and then ask me questions now or later on about that. Now, I've had a 20 plus, let's not count exactly how many years, career. I've only worked for 4 different companies, and really only 3 different, 3 because Motorola sold a business to General Dynamics. And so I didn't change but the logo on the sign did. So I worked in defense technology for a long time. And after over 15 years there, I reached a point where I realized that I was too comfortable. It wasn't that I wasn't working hard or working on new projects or working on new technologies, but the role I was in, I wasn't, I'd kind of mastered it and I wasn't really stretching myself anymore. And I felt like I was starting to get a little bit too comfortable and a little bit too stale. And so I did what I called to my friends jumping out of an airplane and moved to a totally different industry, which was fantastic because there's totally a bunch of cloud stuff in government work, but that wasn't the part that I was in. So I was on the part on embedded systems, and I went to this whole new world of cloud and learning about distributed databases like Cassandra. I had to learn a ton of new technology in order to do that. And there were some things about it that were really uncomfortable because of how much learning I had to do. So I guess my number one recommendation in all of this is take risks, jump out of airplanes, and you can't ever stop learning new technology, because once you fall in love with the technology, something comes along and replaces it. We can't stop inventing things. We're continually inventing new things. So don't stop learning. That's my number one advice for you. I think that's the end of my slides. That's
All
it.
right.
So I wanted to call out one more thing here real quick. So I put, did you get rid of my screen share?
No. You're
okay, good. And I can put this stuff later. I'm on Twitter at JSCarp, CARP. And then I'm working on pretty actively on a couple of open source projects. Cassandra.io is running Cassandra on Kubernetes. And Stargate is an API gateway for Cassandra. So these are a couple of projects that I'm really heavily involved with right now, as well as the Data on Kubernetes community. And Patrick McFadden is a colleague of mine. He and I are writing a book on data on Kubernetes. So you're going to start to hear more about that as we get going with it as well. So there's lots of fun stuff going on. Please reach out and connect. And what questions did I miss that I should have answered?
I'm not sure we can answer all the questions.
Yeah.
But
Are there too many?
There are a lot of questions.
there are a lot of many.
And also, just for folks right now, the questions have been absolutely incredible in the YouTube chat. If you want them answered directly, highly recommend it. Highly recommend going into our Slack and join the channel that's called Beginner Questions. It's not called Beginner Friendly because some folks were a little bit confused. But anyway, Jeff can answer your questions one by one there. Also, probably the best way is to just review the questions that are in the chat. We can do that afterwards and then kind of address them accordingly in Slack because we got a lot of questions. And regarding resources, we already put a couple links. I mentioned previously for folks that just want an introduction to cloud native and things like that in Kubernetes, etc. I highly, highly recommend checking out the talk that we did, the launch for the CNCF students group, where there's a bunch of stuff where you can get started there. Some of the questions as well too. I just want to say, while these were incoming, my technical level is quite low. If you Google some of these questions, you will find answers pretty quickly too. I'm just saying for some things, basic ones, about images, virtual machines, things of that nature. But the rest, like I said, definitely get in our Slack and you can check them out. To repeat as well, okay? What's the challenge here? Because some folks arrived a little bit late. If you want to win swag, if you want to win prizes. The challenge is write a summary about what Jeff has talked about. All right, you can just rewind and watch his talk again. All right, so write a summary. Try not just to copy everything he says. We want to hear this in your own words. A maximum 250-word summary of what Jeff has talked about in this introduction to Docker. Write that down and you will send it to me in our Slack. All right. You'll send it to me directly. Find me in our Slack, message me, ping me. And we'll take it from there. Right. Kunal and I are going to be revising the text that you create. Based on that, we will decide on a winner. The winner will have their text turned into a video that will be animated and also with some images, some photos, etc. You will record your voice. All right. You don't need to record your voice now. You just need to write a text that's a maximum of 250 words explaining what Jeff has talked about in your own words. All right. Very, very important. Already getting asked about the deadline. The deadline is tomorrow. All right. So you have until midnight tomorrow, wherever you are in the world, to get that finished. All right. So Friday, by the end of Friday, we will need to have that turned in. And then we will be able to decide the winners. Like I said, there will be a first prize, getting a video and some swag. And then other prizes for participants. As Kunal mentioned as well, there's tons of other swag to be given away for folks that ask good questions. So keep the questions coming in here. You can also keep them going in our Slack. Like I said, you'll have links to our Slack in the description here in YouTube. And then the channel, as I mentioned previously, is beginner questions. Right. So hashtag beginner and dash questions. So you can get that in there. All right. That being said, if there's anything, Jeff, that you've seen in terms of questions that you would want to answer now, or perhaps common problems that you think folks have when getting started on Docker, anything you want to address directly right now before we turn it over to Kunal?
There's one question that popped up that I thought I would talk to you real fast. So Abhishek asks, I don't know if this is a controversial question. Does Kubernetes support Docker? So I was thinking about this. If you think Docker as a technology has an engine or a runtime that runs containers, but then it runs containers based on images, and the images have a certain format to them. So Docker specifies basically like two things: an image format and then a runtime for running those as containers. So Kubernetes is actually working on phasing out the engine, the Docker engine, as one of its supported runtimes, because the Docker engine does not conform to this API, the container interface that's part of Kubernetes. So the engine itself is not going to be running in Kubernetes anymore, but the container format, the Docker container format, isn't going away. So hopefully that distinction makes sense. So the answer is, in the end, the answer is yes and no.
Yeah, as Bart mentioned, like, please send all the questions in the beginner questions channel. All the links are in the description. Please do check it out.
Yeah, and also we will be posting the link to Jeff's slides. We can even put it in the description later on here. But first and foremost, we'll put it in the Slack channel so you can get a hang of that. All right.
Yep.
There will also be a piece of art that Nelly will create to give a visual summary of what Jeff's been talking about. So you'll be able to find that in Twitter. But absolutely impressed by all the questions we've been getting here in the YouTube chat. Great participation. So thank you all very, very much.
Yep. But we're not done. We have one more session.
Oh no!
Which is
we are not done.
Intro to open source. This is going to be a quick one. Let me just share my screen real quick. How do I present? Cool. So yeah, this is a session on like intro to open source, how you can get started with open source. As a student, open source, first of all, it's for everyone and every contribution counts. So it's a quote I really like. In real open source, you have the right control your own destiny. That is pretty much very, very true. And let's talk a bit more about like what the criteria for open source mean. Open source projects does not really mean like, it's free. It totally depends on like the licenses, but it does mean like you can access it. You can like, for example, modify it all depending on the license that has been provided. And open as in for free, open as in for like anyone from everywhere, and open as in for reuse. So like Android is an open source operating system. Many other organizations and many other companies do use it. Open source, this is a misconception many students have. Like, does it mean that it's actually totally like free and stuff like that? So not really. It totally depends on like the license. Many companies have their open source projects and they're still earning revenues in like billions and stuff like that. So open source licensing is very important. So this is a more important slide. Why embrace open source? Get the quality and reliability, the security and stability, adaptability and customization, freedom and flexibility, and the one of my favorites one is like the cooperation and community. I know many people who prefer like using open source software over proprietary software just because of like the community part. So if you're using some library or framework, you want to request a feature, you can like open an issue or like open a PR or something like that. All right, here's like a few examples of open source projects. This is like the open source development model. You have like the project lead or like a few maintainers, and the volunteers are us. We are who are contributing to their projects, the particular project. So you send in your code, for example, and then the maintainers review your code, ask for any changes, and give the feedback. And once the code and everything looks good, it gets merged into the main project. We can do another session on like use intro to like Git and GitHub and all these things. Let's talk a bit more about like why contributing is important from a student's point of view. So contributing to open source, you will get real world software development experience from the comfort of your home. You get the community bonding exposure. You can get to test your skills, and you'll get the satisfaction of working on a really big project. I met some amazing people, like Bart and people in the CNCF community, and this Jeff and this, and so many people, all the people on this stream as well, and all the people who have been on our channel. Channel is completely focused on open source, right? So met some lot of amazing people, and I've got a lot of opportunities via open source. So yeah. All right. Shout out to CEO first of all for that. So stepping into the first world, important question: prerequisites. If you're talking about like code contributions, because there are non-code contributions as well, I would highly recommend you check out the paths to non-code contributions panel from KubeCon Europe. That's a pretty interesting one. You can find the recording on the CNCF YouTube channel. If you just Google it, you will find the particular video as well. But yeah, so basics about like Git, programming language of your choice, basic to medium knowledge of your tech stack. Again, this is only for code contributions. For non-code contributions, you don't require most of these things. Now, the question that I get a lot of times is how to actually choose an organization. So the Summer of Code with google.com/organizations website is a good place to start. There are two approaches. First, you can like learn the skills and then choose the organization, or you can choose an organization, then learn the skills. Both of these approaches work simultaneously, because if you're a beginner, then you will find yourself in a place, if the project is really big, then you'll be like, there are so many technologies being used in this project that I don't know much about. That is totally fine, because then you can learn on the go and also contribute. So it's totally fine if you don't know everything that is being used. But yeah, learning and having an open mind is important. 3 pillars for successful integration into any organization. Just like, be active in the community, look for projects in that organization that you like, and look for open issues and fix them. Pretty simple, right? So talking about like issues and stuff, learning it is something we already covered. Pick up like beginner friendly issues, the issues that are like really, there have just been like for beginners. If you are not able to find any beginner friendly issues, you can comment in the public channel as well. Like, hey, I'm a beginner. Can you suggest me some beginner friendly issues to work on? Then you fix on that, and then you merge the pull request, and then you go over and over again. You can even start by contributing to the documentation, providing examples and things like that. Few things that I wish I knew before open source was you don't need to be a pro. You don't need to be from a computer science background. You don't need to understand the entire code base in order to contribute, because these code bases are like divided into modules and packages. In case you're this was a GSOC slide, so I'll skip that point. Interact as much as you can with other developers. They have like office hours and stuff. Never be rude, and always participate in discussions, and always follow the code of conduct. Most of your time is going to be spent in research if it's a really big project and you're just like starting out, understanding the code base, learning new technologies, studying the trends of various organizations. That's totally fine. That was a quick summary because I've given this talk quite a lot of times. But yeah, I mean, I have one more call to attend. But anyway, I believe that gave you all a pretty nice idea about open source in general. Cool.
Really, really good stuff. Kunal, I've seen a couple of comments. We're already getting some of the folks commenting in our Slack and sending me their summaries. Mm-hmm. Just as a reminder, we want this to be like a narrative text, okay? Don't just like copy and paste bullet points. We want you to be like telling us a story of the things that you learned. Hello, my name is so-and-so, and today I attended a session that was given by Jeff. I learned 3 different things. Focus on some core things that you learn and tell us about it, all right? Not just copy paste. We want to hear the actual description, explanation, right? So just write that, and don't worry, like if you don't get it right 100% the first time, I'll kind of guide you, give you some tips. So just write me directly on Slack. You don't need to post your summary in any channel. We don't want people copying your ideas. But anyway, already getting some good questions. Jeff, you're going to be very busy for the rest of today because we got a lot of questions. We got a lot of questions going. So once again, just responding to questions in the YouTube chat. Send me your summary directly. Send it to Bart on the DoK Slack. We'll be taking them. I'll be sharing them with Kunal. We'll be giving you feedback. And then, like I said, from there, we'll be choosing the winners. We've got a lot of swag to give out. Big shout out to Sivo for the support. Big shout out to the CNCF as well, too. There will be DoK Slack. I've heard some comments, seen some comments about my t-shirt. Nellie's got her DoK t-shirt is on as well, too. Anyway, so I think
that's pretty much yeah, that's pretty much about it. And yeah, thanks a lot for joining, everyone. Let's play the rap song for you all before we wrap up. But we'll be doing more and more such sessions monthly. And yeah, first of all, last but not least, like thanks to Nelly and Jeff and Bart for joining. Please check out all the links in the description. Check out the DoK Twitter handle because Nelly will be posting the artwork over there by Nelly. So yeah, do check that out. And yeah, let me just open up the rap for you all.
Let's do it.
Here we go.
Let's do it.
Thursday, a rocker shocking shot since the first grade. Got a call from Kunal D to Jazzy Jeff, putting heat on the set, don't look back cause I got no regrets. It's an intro to Dr. Like with Jonah in the whale, CNCF students group, that's magic entailed. Gathering, slathering, jabbering, knowledge, sitting for college, dookie gas or plasma, it's stateful, ran rock solid, prizes on deck, swag up on my neck, the pen is mightier, so I'm signing the check. Collecting containers like Tupperware, this upper step, the hardest to climb. But we appreciate your presence as a present. Many thanks for your time. Yo, we got CNCF students taking on Kubernetes intro to Doctor plus some love from Sivo. Check it out.